They use row upon row of tiny metal balls or columns, which are ceramic, called CBGAs, and metal tape, called TBGAs. BGAs offer a number of advantages over leaded packages, such as quad flat packs or QFPs. Because of their high density and high I/O count, they take up less board space than QFPs. They're also easier to assemble and have better electrical and thermal performance. BGAs are more robust than leaded components, such as QFPs. This means that lead coplanarity concerns are minimal. Also, most BGAs are self-centering or self-correcting during reflow, and ball replacement is difficult on an otherwise good device. Components are susceptible to absorbing moisture from the environment. This can cause a catastrophic mechanical failure called the popcorning effect. Popcorning rework issue is solder paste printing. Most BGA solder defects are traceable to printing. Correct solder paste volumes are essential. Excessive solder volume increases the height of the solder fillet. This can produce geometries with stress concentration or bridging. Too much solder increases the center of gravity, thereby increasing chances for cracking. Insufficient solder volumes can produce weaker, low-reliability solder. This includes sides, internal die, and adjacent components. In terms of preheating, local underside spot preheating can cause multi-layer PWB warpage. Large wide-area preheaters are the most effective. Next, remove the frame. Apply water to the top of the solder ball carrier and soak for about 30 seconds. The water will loosen and dissolve the water-soluble paper. Then remove the paper